Welcome to episode 47 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
From quantum to edge computing, the future of data infrastructure is evolving faster than ever.
Absolutely, Jonas. It's not just about bigger servers anymore. It's about smarter, faster, and more distributed ways to handle data that can transform whole industries.
Let's begin by defining what we mean by data infrastructure. At its simplest, it's the collection of physical and virtual resources that store, manage, and process data. This includes servers, storage devices, networks, and increasingly cloud services.
Exactly. But the game is changing. Traditional centralized data centers are giving way to hybrid models that combine the cloud, on-premises setups, and something called edge computing, where data processing happens closer to the source, like on your device or nearby hardware.
That's a critical point, Amy. Edge computing reduces latency by minimizing the distance data travels. Imagine driving a car with AI-powered sensors, making real-time decisions without needing to consult a remote server halfway across the world. This drastically improves responsiveness.
I've seen this firsthand in automotive projects. One client used edge computing to enable faster reaction times in their self-driving cars, avoiding obstacles and adjusting to road conditions on the fly. Cloud connectivity was still there, but the edge took on the heavy lifting for split-second decisions.
Now, let's bring quantum computing into the picture. While edge computing focuses on location and speed, quantum computing promises exponential leaps in processing power by leveraging the quirks of quantum physics, like entanglement and superposition.
Right. Although quantum is still in early stages, industries like finance and pharmaceuticals are already exploring it. For example, banks are interested in quantum algorithms for portfolio optimization and fraud detection, which can handle complexities classical computers struggle with.
Quantum computers work fundamentally differently than classical computers. Instead of bits being either 0 or 1, quantum bits, qubits, can be both at once. This ability opens new doors for solving problems like optimization, cryptography, and complex simulations that impact data infrastructure planning.
That said, integrating quantum computing into current data infrastructure presents huge challenges. Quantum hardware is fragile, expensive, and requires specific environments. So most organizations think of quantum as a complementary tool, not something replacing their existing systems anytime soon.
Indeed, which brings us to the idea of next-generation data infrastructure. It's less about one technology dominating and more about orchestrating a rich ecosystem, combining traditional data centers, cloud, edge nodes, and eventually quantum processors.
That orchestration is a big theme for companies I work with. Take healthcare, for instance. Patient data from wearables and hospital equipment gets processed at the edge for instant alerts, while more complex analysis happens in the cloud. AI models run continuously, but leveraging the right infrastructure mix is key for speed and compliance.
And from a theoretical perspective, this heterogeneous approach follows the trend toward distributed intelligence. Instead of centralizing all the data and decisions, we push compute closer to data sources and users, while keeping heavy analytics centralized.
Plus, it improves privacy and security. Processing data locally, like on your phone or a factory floor device, means sensitive information doesn't always travel across networks. That's increasingly important with regulations like GDPR and HIPAA.
Absolutely. Another future consideration is data interoperability. As infrastructures evolve, various systems and devices need standardized ways to communicate, whether it's sending data from edge AI sensors to cloud analytics or to a quantum backend.
Speaking of that, I've worked on projects where interoperability wasn't up front, and it caused huge headaches. Different teams used incompatible data formats or protocols. It delayed deployments and raised costs. Getting infrastructure standards right early saves time and money.
So what about the infrastructure software layer? Containerization, orchestration with tools like Kubernetes, and AI-driven monitoring are reshaping how data systems run and scale.
Definitely. Automated management helps companies deploy AI models across different environments seamlessly. I remember a retail client that used AI to optimize inventory. Models ran partly on the cloud and partly on store-level edge devices. Automation made sure updates and scaling happened without downtime.
That's a great example of resilience and agility in data infrastructure. We're moving toward infrastructures that adapt dynamically to workload demands, data volumes, and latency needs.
One more thing, energy consumption. As data infrastructures grow more complex, sustainability becomes critical. Both cloud providers and companies invest heavily in green data centers and energy-efficient hardware. It's not just a cost issue, it's a business imperative.
A solid point, Amy. From a framework view, we can see future data infrastructures as multi-layered, combining compute layers, edge, cloud, quantum, orchestrated by intelligent software and aligned with privacy, security, and sustainability principles.
It's exciting, but also overwhelming for companies figuring out where to start. My advice is to focus on business outcomes first. Understand where latency really matters, what data is sensitive, and which processes can gain from edge or quantum advancements.
Then, build infrastructure incrementally. Start with hybrid cloud and edge integration to gain agility. Keep an eye on quantum developments, but don't wait for a silver bullet.
Exactly. And don't forget the people side. Having skilled teams who understand this infrastructure ecosystem and can collaborate across IT, data science, and business functions.
So, to wrap up, Amy, what would you say is the key takeaway here?
The future of data infrastructure is about combining multiple technologies, edge, cloud, and quantum, to create flexible, efficient, and secure data ecosystems that directly support business goals.
And from my side, understanding the theoretical underpinnings and frameworks of these next-gen infrastructures helps leaders make informed decisions and anticipate future trends.
Next time on 100 Days of Data, we're diving into AI and human augmentation, exploring how AI tools enhance human abilities and what that means for workplaces and society.
If you're enjoying this, please like or rate us 5 stars in your podcast app. Leave your comments or questions, and we might feature them in future episodes.
Until tomorrow, stay curious, stay data-driven.